Good evening, everyone. Today we're going to start a chapter called Derivative, and this is going to be our first video on derivatives. Derivative or differentiation using first principle and direct differentiation. These are the two main topics that we have to cover under derivatives. And today I'm going to concentrate only on direct differentiation. First principle will be taught to you later. So direct differentiation. The first one under direct differentiation are few standard derivatives. Look, I'm going to list out some 13 standard derivatives, and some of them I'm going to give you examples, some I want you to memorize it as it is. Then later on I'll show you the proof of all these things, one by one, using the first principle. The first one in that is derivative of x to the power of n, where n belongs to any real number. Derivative of x to the power of n, where n belongs to any real number. Now when we differentiate something, it simply means rate of change of one with respect to other. And many cases we always have functions in terms of x represented by y equal to x cube, y equal to x square. So when x changes, automatically y changes. So imagine if y equals to x to the power of n. When I say d by dx of x power n, it simply means the rate of change of x with respect to the rate of change of y with respect to x. So what happens to y value when x value changes? So that is what derivative means. Now, d by dx is the notation that we use to indicate that we are differentiating that term. So when we put d by dx, it means that we are differentiating that term. So differentiation of x to the power of n with respect to x. Always with respect to x until and unless the question specifies for some other variable. Always with respect to x only. So x to the power of n differentiation where n belongs to any real number is n x to the power of n minus 1. Now I've given some examples to understand this. Differentiation of x square. What is x square? X square is y. Y is equals to x square. So which means when x changes, how much y changes? So what is the rate of change of x square when x changes? So when I differentiate x square, I have to use this principle. So which is the power will come down and power will be subtracted. 1 will be subtracted from the power. So x square differentiation is 2x. What happens if the power is a fraction number? The same thing, because n applies for any real number. So even here, the power is half, the half comes down and half minus 1. So half into x to the power of minus half. 1 by 2 minus 1, simplification is minus half. Now since the power is negative, you take the term to the denominator. When the term is negative, you bring it down. When the power is negative, you bring it to the denominator. So it will be 1 by 2x to the power, 1 by 2x to the power of half, which is 1 by 2 root x. Now, what is differentiation of 7 into x to the power of 7? This 7 is a constant and it will not change with respect to the change of x. So I can take x out of the 7 out of the differentiation and differentiate only x to the power of 7, which is 7 x to the power of 7 minus 1. The same principle, power is brought down and power minus 1. Eventually you get 49x power 6 as the answer. Differentiation of x cube, where n is 3 here. So n x to the power of n minus 1, 3x to the power of 3 minus 1, which is 3x square. Differentiation of x, x meaning power is 1. So power comes down and power minus 1. So 1x to the power of 1 minus 1, which is 1x to the power of 0. Anything to the power 0 is 1. So answer is 1. Next one, differentiation of x to the power of 1 by 3. 1 by 3 x to the power of 1 by 3 minus 1. And 1 by 3 minus 1 simplification is minus 2 by 3. Again the power is negative. You bring it down. Next example, differentiation of x power 5 plus 6. X power 5 is an x function, therefore when x changes, x power 5 will change. So it will be 5x power 4 using x power n rule. But 6 will not change. Whatever x change, 6 will remain as 6 only. So differentiation of 6 is 0. Last example, differentiation of x cube plus x square plus x plus 3. Differentiation of x cube, I've already done it above, I'm doing it again. 3x square. X square differentiation 2x because power comes down, power minus 1. X differentiation 1 and 3 differentiation 0. So the answer of this is 3x square plus 2x plus 1. So these are all differentiation of algebraic functions. So I've just listed out some important derivative of algebraic functions because this will come in most of the questions. So what is differentiation of root x? We just did it over here. What is root x? Root x is x power half. So root x differentiation answer is 1 by 2 root x. So therefore, whenever root x comes, we will not have time to do the whole process. Therefore, differentiation of root x is taken as straight away as 1 by 2 root x. If you want initially for few sums, you can try, but later on you have to adopt yourself to apply this directly. Differentiation of x is 1, differentiation of constant is 0, always. Now, differentiation of log and exponential functions. Differentiation of log x is 1 by x. Differentiation of e to the power of x is e to the power of x itself. If it is a to the power of x, it is a power x into log a base e. Differentiation of trigonometric function. Differentiation of sin x is cos x. Cos x is minus sin x. Tan x is secant square x. Sec x is sec x at tan x. Cot x is minus cosecant square x. Cosec x is minus cosec x cot x. So trigonometric functions, differentiation is listed out. But it doesn't mean there is no differentiation for any other term other than this. There's nothing like that. Every term can be differentiated, but these are standard derivatives. So if you know this, you can smoothly start the basic questions. Later on, we will learn how to differentiate the answers that we get here. Like we can differentiate secant square x. We can differentiate minus cosecant square x also. We can differentiate sec x tan x also. But how to do it, you will learn it once you're thorough with the standard derivative. Method of differentiation. Under methods, we have three main methods: product rule, quotient rule, chain rule. Product rule is when you find two x functions in product form. Remember, two x functions which cannot be multiplied. If it's x square into x cube, I can write it as x power 5 and I don't have to use product rule for that. But if it is x square into cos x, then it can't be multiplied. There we use product rule to differentiate. Remember, when we use a product rule, at a time only one function will differentiate. So it's u into differentiation of v plus v into differentiation of u. Now, if the question is in division form, we use quotient rule to differentiate that. So v into du by dx minus u into dv by dx by v square. V into du by dx minus u into dv by dx by v square. And last but not the least, chain rule. Very important topic, and I'm not giving any formula for that. We'll have a session for that. So first question, find the derivative of x square minus 2 at x equal to 10, x at x equal to 1, 99x at x equal to 100. It's the first one. So they want us to differentiate x square minus 2 and then find the value of that derivative when x is 10. So let's first differentiate. In order to show that we are differentiating that, we have to do d by dx of x square minus 2, which is d by dx of x square minus d by dx of 2. D by dx of x square is based on x power n root. So you get 2x to the power of 2 minus 1. And d by dx of 2 being a constant, differentiation is 0. So answer is 2x. Now find dy by dx of x square minus 2 at x equal to 10. We already know the answer is 2x. So 2 into 10, 20. So this is the first question. Now second one. Find the derivative of x and what is the value at 1. So derivative of x is 1. Okay. Now what is derivative of x at x equal to 1? Well, I don't have a place to substitute this one. It's already 1. So answer will remain 1. C. Find the derivative of 99x. 99 is a constant, x is a variable. So take 99 out of differentiation and differentiate only x, because x changes, which means y changes, and y's change will be respect to x only, not with 99. So 99 will not affect. Therefore, we take 99 out of differentiation and we write this as d dx of x, which is 1. So 99 into 1, 99. Now what is differentiation answer at x equals to 100? Where is x to substitute 100 here? So answer will remain 99 only. So the next question, find the derivative of x cube minus 27. Find the derivative of x minus 1 into x minus 2. And then find the derivative of 1 by x square. So question number 1. Differentiation of x cube minus 27, which is differentiation of x cube minus differentiation of 27. X cube differentiation is using x power n rule. So 3x to the power of 3 minus 1. 27 being the constant, differentiation is 0. So 3x square is the answer. B. Differentiation of x minus 1 into x minus 2. Well, if you see, this is in product form only. There is no doubt about it. We can use the product rule, but right now we are not going to do all that. Being two x functions, I can comfortably multiply them. If it's an algebra and trigonometry, if it's an algebra and some other function, or a trigonometry versus exponential, then there is no way to multiply. We have to follow UV rule. Here, being two algebraic functions, I can comfortably multiply them. So I'm going to multiply and then differentiate. So still differentiation is not over. So it is mandatory to put d by dx. So x square minus 3x plus 2 will be the product of these two terms, which is now d dx of x square minus 3 is a constant, will stay out of differentiation. Differentiation of x plus differentiation of 2. Differentiation of x square is 2x. Differentiation of x is 1. So 3 into 1. And differentiation of constant is 0. So 2x minus 3 is the answer. And the last one, which is differentiation of 1 by x square. Now, the x power n rule applies only when the x is in the numerator, not in the denominator. You can use u by v rule here, but as I said in the beginning, I am not going to get into those methods right now. So I am going to write this as d dx of x to the power of minus 2. Now use x power n rule. So don't make the mistake of applying x power n rule by keeping x in the denominator. You have to bring it up and then use the rule. So minus 2 x to the power of minus 2 minus 1. So minus 2 x to the power of minus 3, which is minus 2 by x cube. Okay, the next question, I've already worked it out. F of x is equal to x power 100 by 100, x power 99 by 99, so on till x square by 2 plus x plus 1. They want us to prove f dash of 1 equals to 100 times f dash of 0. Now, what is all of a sudden the dash stands for? The dash stands for the derivative of the function. This is another way of denoting it. So f dash of x simply means d dx of f of x, derivative of f of x. F of x is nothing but y, remember that. Always f of x means y. So f dash of x is equal to d dx of f of x. Now f of x, whatever is given in the question, I have written it again. Now let us differentiate each term whichever is there in the series. So f dash of x equals 1 by 100 is a constant and we will differentiate only x power 100. So 1 by 100 is taken out, differentiate x power 100. Likewise, 1 by 99 is taken out, differentiate only x power 99. Like that, 1 by 2 is taken out, differentiate only x square. X differentiation and then 1 differentiation. So here we are showing that we are going to differentiate each term of x. So here x power 100 is the x power n root. So 100 x power 100 minus 1. So 100 x power 99. Like that, x power 99 will be 99 x power 98. X square will be 2x. X will be 1 and 1 will be 0. Now simplify. 100 100 get cancelled. 99 99 get cancelled. 2 2 get cancelled. Remaining is taken down in the next step. So x bar 99, x bar 98, x plus 1. So this is our f dash of x. Now what do we need to prove? We need to prove f dash of 1 equals 100 times of f dash of 0. So LHS is f dash of 1. What is f dash of 1? In the place of x, you substitute 1. So wherever there is x's, you substitute 1 there. So 1 to the power of 99, 1 to the power of 98, so on till 1 plus 1. Now 1 plus 1 plus 1, and how many ones are there? 100 ones are there, because look at the power. 99, 98, so on, this will be 0. And this is one more term. So if you total it out, there will be 100 ones. So the sum will be 100 into 1. 100. Now RHS, which is 100 f dash of 0. What is f dash of 0? Substituting 0 in the place of x. So 0 power 99, 0 power 98, so on, 0 plus 1. And if you find the sum of this, everything is 0 except 1 will stay. So 100 into 1 is 100. LHS is also 100. RHS is also 100. Therefore, f dash of 1 equals to 100 times f dash of 0. So that's it. Part 1 video of derivative is completed. Do watch it again and try all the sums. Thank you.